Vision Corps presents ARMD Speaker Series, Invisible Disability, Living with Macular Degeneration, with Christine M. Donmoyer, PhD.
Welcome to our webinar series. Before we begin, we'd like to tell you a little bit about our services and who we are. Vision Corps is a nonprofit organization that empowers people with vision loss to attain independence. We offer a variety of rehabilitation services, including occupational therapy, case management, safe travel instruction, support groups and education, access technology, and more. Please get in touch with us by calling 717-291-5951 or emailing info@visioncorps.net for more information.
So welcome everyone to our first macular degeneration presentation. We are very excited to have all of you on today. We're looking forward to this macular degeneration speaker series being an event that we do quarterly. So before I introduce our wonderful first speaker for today's presentation, I just want to let everyone know we are recording again this presentation. That way we can post it for those who are not able to join us today, and in case any of you on the call today would like to listen or view it again. There will be some slides that we will be showing, but again, we will be making sure to fully describe all of the slides for everyone. So just a little bit of housekeeping. Again, we will be asking everyone to stay muted and video off if we can during the presentation. And then we'll let everyone know when we're ready to take questions at the end of the presentation. And if you're on the phone, that would be *6 to unmute yourself. And if you're on video, there's an icon across the top that you can unmute yourself. So again, we're very excited for today's presentation, but we do want to tease a little bit about the next presentation that we will be having in February, which is Macular Degeneration Month, or Macular Degeneration Awareness Month, I should say. We will be looking forward to having Lancaster retina specialists presenting on the new injections for dry macular degeneration. So we're finalizing, the details of that. And once that's finalized, we will send information out about that. So again, hopefully all of you will be able to come back for that presentation. Very good. So on to today's presentation. We're very excited to have Dr. Christine Donmoyer present with us today. She was diagnosed with Stargardt's disease, which is an early form of macular degeneration at 27 years old. So she both has a personal experience with low vision, but she also is going to be discussing her new book called Invisible Disability, Living with Macular Degeneration, in which she addresses the challenges that people with macular degeneration experience in everyday life. So her work applies to those newly diagnosed with macular degeneration, as well as those who support them. And the book's exploring emotions and coping mechanisms, as well as practical solutions to living and thriving with macular degeneration. So currently she works in the pharmaceutical industry and holds a PhD in molecular physiology and biophysics from Vanderbilt University. So I'm very excited to introduce again Dr. Christine Donmoyer, and I'll turn it over to her while I get your slides up on the screen. Okay?
Wonderful.
All right, one moment. Let me get those slides up and I'll let you know when I have that up for you. Okay. All right. Now, are we seeing the slides? Any of the case managers on the call today?
Yes.
Okay,
Yes.
very good. Well, then I'm going to turn off my mic and turn it over to you, Dr. Donmoyer.
Well, thank you so much, Linda. I can't believe the day is finally here. We've been planning this for several months. I want to say thank you so much for inviting me to this format. I'm still learning some technology things, so I guess the next thing I need to do is remind my husband not to take my notes from my table. But we're going to go without notes. How about that? So, thank you again, Vision Corps, for inviting me. My name is Christine Donmoyer, like done with my taxes, Donmoyer. And I'm here to tell you a little bit about my experience as a patient and also as a vision researcher. And let me just kind of go by cue. Linda, so far, can you see me? Can you hear me?
Yes, I can.
Okay, any changes?
Are we doing okay with sound and everything? I think we're good. And I have your slideshow pulled up here.
Wonderful. I'm still kind of amazed at how well the technology is working. Thank you so much. All right, folks. So, what can I tell you about macular degeneration and what I've learned? Let me give you kind of my diagnosis story. It is unique, but then you'll find that there are a lot of similarities to those of you who have macular degeneration, and those similarities will come across later, not so much in the actual diagnosis story. So, let's try the next slide. So the slide that's going to show next is what I call the Amsler grid, and actually doctors call it that too.
One moment. There we go. I think I got it. All right.
Very good. So for those of you who are not familiar with it, it is a grid of white background, black grid, and it really, I don't know how else to describe it, is like a checkerboard kind of grid. And what a retina specialist will do at an eye exam, and sometimes they'll have you do this even before you see the doctor, and that was the case that I had. Let me begin at the beginning, right? So in the year 2000, I was 27 years old, and my sister was just a couple years younger. She was experiencing some vision problems while she was driving to work, and she was also pregnant at the time. And so once she saw a doctor, the doctor suggested that she might have an inherited form of a vision disease. But since she was pregnant, he didn't feel that he could do any testing on her. So he suggested that her immediate family members go see retina specialists and get tested, kind of a preliminary step. So even though I believed she was full of the pregnancy drama, I agreed and went to see a retina specialist. At that point, I was in Nashville, Tennessee. I was working as a graduate student at Vanderbilt University. So fortunately for me, I was able to hop across the street and talk to a doctor. Also fortunately for me, I met a retina specialist who is one of the best diagnosticians, the people who diagnose people. On the other hand, that means that they don't have what we would call the best bedside manner. So there are trade-offs to what kind of doctor you are dealing with. So I met this doctor in March of 2000. And when I did this Amsler grid, I wasn't able to see the entire grid. And this was my aha moment of, wow, maybe I do have a vision issue. Maybe my sister is right. So when I looked at the grid way back then, they asked me to indicate any spot on the grid that was clear when I would expect to see the grid. So let me see if that makes sense. On the next slide, it will show you what it looked like for me back then. And the next slide shows both the left eye on the left and the right eye on the right. And this was, dating back to March of 2000. On the right eye, I drew a small circle. The circle was more like a bullseye in the center of the grid. And in that bullseye, I could still see in the middle of it, but there was a faint line, if I could call it that I could not see the grid lines. On my left eye, I barely had any problems, but when I looked very closely, there were a couple of grid lines that I could not see. And so I drew a very faint circle that indicated where I could not see on the grid. When I look back at it now, 23 years later, I think, wow, like my vision was barely affected, but it was still that warning call of, wow, is this what they call a macular issue? Because I had at no point before then anticipated or realized that I had a vision issue. Besides my normal issue prior to that, I was wearing contact lenses to correct myopia. I was nearsighted. No other issues besides that. So during that visit with a doctor, he suggested that I might have a macular issue. I believe the word he used was macular dystrophy because I was younger. And he kind of left it at that and said, come back and see me in a few months and maybe we'll do more.
Oh,
Any questions so far? Okay. So that story might be very unsimilar to anybody else in the group, but you'll find later on we get some similarities. So during the next month, I had a moment with God. It happened to be on a beach because I was worried that I was going to lose my vision entirely. And why did I think that? Because after I left the doctor's office, while my eyes were returning from the dilation, a nurse spoke to me and she said, "Oh, don't worry, honey. You probably won't lose all of your vision." Which, of course, was the sign that I would think, maybe I am going to lose all of my vision. That's not what the doctor had said. It's what the nurse had said. So I proceeded to do a very intense internet search. And this is back in the year 2000, and I hadn't done a whole lot of those. I read about every vision disease. I didn't understand most of what I was reading, but I dug in and started reading more. And at some point, I encountered someone describing a vision disease called Stargardt disease. And what I read didn't sound exactly like what I have, but I thought I need to find out to make sure I don't have that. So when I went back to the eye doctor in May of 2000, so not even 2 months later, I asked the doctor, could we do this test that rules out whether or not I have Stargardt disease? Spoke with the doctor. He said, Christine, I don't think you have it, but hey, if you want to do this test, I guess I'll do it. And the test is called a fluorescein angiogram. It's such a long term, they usually call it an FA. What the test involves is staring at a camera where the camera takes multiple pictures of your eye. You have a bright light on the entire time, and you sit there for about an hour while a dye has been injected into your vein, and that dye, over the process of an hour, will move into your eye, into your retina, and it will identify blood vessels and whether or not the blood vessels are working. It also identifies whether or not cells in the retina are functioning. So all of that to say, the next day, the doctor called me and he said, well, Christine, the fluorescein angiogram results came back and you've got classic Stargardt disease. And at that point, the reality hit me of, wow, I really do have a vision disease. And it's this thing that I read about that sounded awful, and now I have it. So of course I asked him, has the prognosis changed? Like, what is the state of my vision? And at that point, my acuity was 20/25 and 20/30. Very minimal effect in terms of my vision, but I knew it would get worse. According to everything I had read, it said that a person with Stargardt disease would reach legal blindness within 5 years. And when I was 27 years old, that really seemed pretty devastating. In 5 years, I'm going to be legally blind, but I didn't really know what that meant. So that led to an exploration. If Linda's still around, could you advance the slide, please? Perfect. So just a little bit about Stargardt disease, which we call STGD. Okay. So I told you it was an inherited form, which means that it's caused by one mutant gene. We happen to know what the gene is, and we knew that in the year 2000. It's called the ABCA4 gene. It only is expressed in the retina. It's expressed in photoreceptors, and it seems to be involved in photoreceptor function. So in the mutation that I have, it leads to the photoreceptors dying. That's kind of what we knew back in 2000. How would I compare it to age-related macular degeneration, or AMD? So here's where I have to give you a little bit of my knowledge about vision research that came later. What I think age-related macular degeneration is it shouldn't be called age-related. It should just be called, some people get it later as they age. Macular degeneration means that the cells in your macula die before the individual dies. Like they die too young. And the cause of what causes those cells to die could be several different factors. Okay. Yeah, you can, that's good. Moment of silence while I cough. The cells that die are dying for various reasons. It could be they're not getting enough nutrition or nutrients. It could be that blood flow is impaired, or it could be inside the cells themselves, they're getting a signal to commit suicide. So let's kind of like not worry about the biological reason for the purposes of this talk, but there are several different reasons why cells can die too young. And later on, I learned some of those steps and what we can do to perhaps prevent any of those causes. Let's try the next slide. Okay. Okay, I promised you to compare to age-related.
Can I interrupt for just one moment? If anyone's joining us by video, if you could please turn off your camera. That we are recording it. That way we can make sure that we're just seeing Christy and the presentation. That would be great. Thank you, everybody. Okay, go ahead.
Okay, so based on questions of various doctors and my experience, I would describe Stargardt disease that has advanced in my stage to be similar to a form of dry AMD, and dry is the more common form of age-related macular degeneration. And again, we're not quite sure what the cause is besides photoreceptor death. It is different from wet AMD. In the case of wet AMD, we have blood vessels that are leaking out blood, and when they leak blood, they obviously block our vision so that the photoreceptors don't receive light rays. In the case of dry AMD, the blood vessels are very thin, and the retinal cells don't have very much support, and so those cells end up dying, and they happen to be located in the macula, so that's why we call it macular degeneration. So in Stargardt disease, I would say it's very similar to the most severe form of dry AMD, which is also called geographic atrophy, and some people abbreviate that GA. So if you are first diagnosed with dry AMD, that would be an early stage. If it's advanced, they might call it geographic atrophy. Based on my knowledge of ophthalmology, I would say my disease, Stargardt disease, is like geographic atrophy or dry AMD. Okay, so for those of you out there who have wet AMD, I would say they're not quite the same. In wet AMD, you have leaking blood vessels. I don't quite have that situation, but overall, if you talk about not being able to see, those situations are very similar. Hopefully that makes sense and you can ask questions about it later. So, in terms of what did I do after I was diagnosed? I cried a lot. Fortunately, my boss, my lab advisor, my dissertation advisor, he recommended that we focus on getting my degree, and we did. And about 6 months later, I was able to defend my dissertation and earn my PhD. And there was definitely a turning point soon after my diagnosis where I wondered, was I going to finish what I had started? That was a 6-year process. And I was in my 5th year when I was diagnosed. So I felt like I was too close to give up. But I didn't really know what the next step would hold because I had studied diabetes and I didn't know what a blind researcher could do in that field. I wasn't blind at the time, but I knew at some point I would be legally blind. So I was kind of taking a step into the future, unsure of what I would be able to do. So in 2001, I decided it was time for me to switch fields, not from physiology, but from diabetes. And so I switched my research direction from diabetes and studying the liver and glucose metabolism, and I decided it was time for me to study vision. And even though I didn't study my own disease, I never studied Stargardt disease, I read a lot of articles about it, and I chose a research question that was related to it. So I ended up moving to New York City. I worked at Columbia University, and I learned about mice and how they were fairly good models to study vision loss. And what we could do is manipulate genes and in the mice, and those genes were similar to what humans experienced or had. And we could make mice having vision diseases that were similar to human diseases. And I use the term similar because, of course, they're not exactly the same. There was something called the Stargardt mouse. It's not exactly the same as a Stargardt human, but there are similarities. In case you were wondering, do we have such things as an age-related macular degeneration mouse? Sort of, not exactly. So what we've learned over the last 20 years or so is that because mice live for 2 years and humans live a lot longer, it's hard to simulate exactly the same kind of situation that an AMD person might experience. But there are things that can be similar. So I hope not to confuse you with the science of it, but just to suggest that there are researchers out there who are studying various animals as a model of human disease, specifically to vision disease. And they've been working very hard on macular degeneration, but unfortunately, it has taken a long time to get where we are today. So, one more little piece. After I worked at Columbia, I also worked at Emory Eye Institute and did some more genetic research. And so I was studying the causes of why photoreceptors die. Let's switch to the next slide if possible. Okay. So this is a nice figure of an eyeball. And for those of you who can see it, great, but let me explain for those of you who cannot. The way the figure is drawn, light enters from the left side of the eye. It strikes the cornea, which is the outer surface of the eyeball. And then light rays are transmitted or refracted, bent, towards the lens. The lens is kind of in the first third of the eyeball, and the lens will bend the light rays further. It is a clear, transparent, mostly object within the eyeball, and it changes the direction of the light rays. It bends those light rays so that they move through the rest of the eyeball, through the liquid called the vitreous humor, which is hard to draw because it's pretty much colorless. And then it sends those light rays to the back of the eye, which is known as the retina. Now, of course, I'm biased, but I think the retina is the coolest part of the eyeball. The retina is an extension of the brain. It's full of neurons. The neurons come in many different names and classes. There are retinal ganglion cells. Those are affected with glaucoma. There are bipolar cells. They're kind of the in-between cells between the retinal ganglion cells and the photoreceptors. And then, of course, there are the photoreceptors. Why we call them photoreceptors is because they are cells that detect light. They are just about the only cells in our body that detect light. Only recently have we discovered that there are just a couple cells in the retinal ganglion cell class that can detect light. And there are scientists working to figure out, can we make those cells like photoreceptors and make them help establish images? That's a totally different area of research, but it's a really interesting area of research. So in the photoreceptors, they detect the light rays. They convert those light rays into signals or electrical impulses. Then they send that message to the bipolar cell. The bipolar cell sends it to the retinal ganglion cell, and the retinal ganglion cell sends the message, the electrical signal, to the optic nerve. The optic nerve leaves the eyeball and sends the message to the back of the brain. We call it the occipital lobe of the cerebrum. That's the last little bit of biology I'm going to give you. Next slide, please. So this figure was also drawn by an illustrator known as Bryce Olson. When I was teaching at a college in Pennsylvania, Bryce was one of my students. If he had not become a medical illustrator, he was going to become an optometrist. And so we're still debating about which career he's going to follow. But because he was in my class, he says he wanted to become an optometrist. So I credit that little teaching exercise to helping get another optometrist out there. So this figure is two things. On the left is a cone photoreceptor. On the right is a rod photoreceptor. Just like when you encountered Saturday Night Live and they had the cone head sketch, the cone has a shape like an inverse ice cream cone. And the cone is very cool. Its job is to detect colored wavelengths of light. So there are different cones. Different animals have different kinds of cones, but in humans, we have three main types: the red, the green, and the blue, and they're named based on which wavelengths they're mainly going to absorb. We have a very small number of cones relative to the number of rods in our eyes. There are other animals that have more cones and more different kinds of cones, but we're dealing with humans. For the human retina, we have millions of rod photoreceptors, somewhere around 110 million rod photoreceptors. In terms of cones, we have around 5 million cones. So they're way outnumbered. The rod photoreceptors have one main job. They detect any light that comes near them. They are not as particular with the wavelength that they absorb, but they are so numerous, and they are also able to detect just about any light that comes near them, so they operate in dim light settings. Cones, on the other hand, are particular with what wavelength they detect. They're only located in the macula or the center of the retina, and they require more light in order to absorb. So we have two different kinds of photoreceptor cells. The rods are more numerous, but they're more sensitive. They can detect very low levels of light. And if you were to look at the extent of your retina, the very middle macula is where the cones are. The rods are present in the macula, but the rods are also everywhere else. I'm hoping that makes sense to people. Okay. In terms of their internal structure, how do I put this? There are many layers within the cell, and those layers are chock full of cell membranes. And inside those cell membranes are molecules that are able to absorb light. Those molecules we could call rhodopsin. And the rhodopsin is basically a molecule that's able to absorb light and then transmit an electrical signal. So the great majority of the photoreceptor cell is full of those molecules, as opposed to the other parts of the cell, the nucleus or the sarcoplasmic reticulum or the other portions of the cell that make the cell work. The photoreceptor cells are very specialized for detecting light, and so they're full of those molecules. Okay. Let's do the next slide. So the next thing I'm going to talk about is low vision. And so I need to go back kind of in the history of my life. I was diagnosed in the year 2000, but it wasn't until about 2005 or 2006 that I really started having vision changes. So I went about 5 or 6 years before I really needed to address this vision disease. And so that's actually a really positive thing. I wasn't legally blind in 5 years. It took me 11 years. On the other hand, my sister, she hit legal blindness about 3 years after we were diagnosed. And so if you break that down and say, what's the average of 3 and 11? I guess you get closer to an average of 5 years. So why is it that my sister and I had such different paths for vision loss? I don't know if there's a good answer for that. We have probably the same genes, but we do have different life experiences. Perhaps she was out in the sun more. Perhaps she didn't wear sunglasses as often as I did. Perhaps it was our diet. Perhaps it was the fact that she had 2 pregnancies and I had none. I mean, there's a lot of different factors that go into it. But if you were to examine other Stargardt patients and how it does run in families, there are a lot of differences in terms of at what stage they experience vision loss. I think of it as similar to a person with age-related macular degeneration. They are diagnosed after the age of 50. Some people are diagnosed at the age of 61. Some of them are diagnosed at the age of 82. There's a lot of variation in terms of when the macula degenerates. In my case, I happened to be 27 when I was diagnosed, but I didn't really experience many vision problems until about 5 or 6 years later. So one of the standard things about this disease is that it affects people at different ages. That's what we're dealing with. Stargardt disease is called a juvenile macular degeneration. In the world of ophthalmology, juvenile means before the age of 50. That was kind of odd to me. I thought juvenile meant before the age of 18, and I was 27. But in ophthalmology terms, before 50 is considered juvenile, and after 50 is considered age-related. Okay. All right, so around 2006, I was having problems reading the textbook. And as a college professor, reading the textbook is kind of important. So I was sharing my issue with my boss, my department head in the biology department, and she didn't really care. She just said, suck it up and deal with it. Couple other people said very similar things. Turned out that I was talking to an education professor, and she suggested, why don't you go to a low vision doctor? And I think to myself, wouldn't it have been nice when I was diagnosed in 2000 or at some of my follow-up visits if a doctor had mentioned to me, you might need to see a low vision doctor? But that was not common back then, so I had to figure it out on my own. Thankfully, Paula suggested I go to a low vision doctor. She told me exactly where to find one, and I was living in Jackson, Tennessee at the time. So I went to the low vision doctor and I said, can you help me? I'm having trouble reading textbooks. And she found out that there are 2 devices that, lo and behold, could help me. Let's see what the next figure is. I think I have a picture of one. There we go. So this is known as a CCTV. It's also called a closed circuit television. And because I was employed in Tennessee, I qualified for getting such a device. Basically what I do, on the right side of this picture, I put anything that I want to read. In this case, it was a physiology journal to indicate I still study science. And that journal was projected through a camera. The camera's like above it. That camera projects it onto a screen or a computer monitor. And then on the computer monitor, with just a couple of buttons, I can click large, 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 enlarge it until I get it to the level that I can read it comfortably. So it's basically a very expensive camera with a computer monitor attached. This device ran me about $3,000, and I was really fortunate that my employer actually paid for it at the time. I have one at home now, but so the story of how did I get my employer to pay for it is long and boring. But eventually, when I got a lot of no's from my department head, my supervisor in the biology department, I decided it was time to go to the dean because the dean actually controls the money. And I begged the dean to purchase me this device, and he actually did. So this was a life changer because I would put the textbook or the journal or a newspaper underneath that camera and then project it onto the screen, and then I could read again. So even though my vision was starting to fail, I could still keep up with my reading with this device. It's called a closed circuit television or CCTV, and it has been very important for my rest of my career. If we could advance the screen once more to the next slide, this is my other device. This is called a handheld magnifier. It happens to be made by Eschenbach, Eschenbach, Eschenbach. And I happen to love that company because this is my favorite device ever. I still have one. I got one in 2006, so it's been, more than 15 years. I am on my third one because I've broken the first 2. And now that I've broken them so many times, I carry my little magnifier in an oven mitt. It doesn't look great. Certainly when I take it to restaurants to read menus, sometimes the waiter will ask, why do you have an oven mitt? And then they look and say, why do you have an oven mitt with this weird device inside? But I don't care because this allows me to read a menu, and without it, I have to ask the waiter, what are the specials? And I guess I'll order one of those. So this device happens to be a 2.5 magnification, 2.5x. For many of my activities, I just need a little bit of magnification, and this does the job, but it is portable, so I have to carry it with me. At various times in my life, I've had one at my office and one at home, so I didn't have to carry them between. But nowadays, I do carry this device in my purse, and I keep it handy because I find that on a regular basis, there is something that I need to read or look at more closely, and my eyes just can't do it anymore. So having this device handy is very useful. I will tell you that I've gotten kind of a combination between these two devices. It's called a mini CCTV. It's handheld. It has a light that comes on. This device does not. And that mini CCTV is very useful in my current job. Prices. The CCTV on the previous slide cost around $3,000. Maybe there are some that are cheaper. This handheld device is around $120. I haven't purchased one lately. So if I were to choose between the two, certainly the CCTV is more useful, but it's not portable. The handheld is useful and it's a lot cheaper. I use both depending on what tasks I'm doing. The mini CCTV, which I don't have a picture of, and it just died on me a couple weeks ago, I'm getting a new battery. The mini CCTV is around $800. And in my current job, it is essential, but I still like my handheld magnifier as well. So if I had to choose between the two, gosh, I like having all three. I mean, there's no way around it. I have different tasks that require different devices. And so I end up becoming the bag lady that carries all these devices around. Okay. If I could go back 2 slides, perhaps, I want to point out one more thing that's on the slide. Okay, so at the low vision doctor or evaluation, the doctor suggested to me that I get the CCTV and I get that handheld magnifier. So then I had to investigate, how do I purchase these things? Fortunately, I could afford $120. The $3,000 my employer paid for. Other people go to a low vision doctor for different purposes. I needed to read small print, but other people might have peripheral vision loss. They might need cane training, how to use a white cane or a special cane that indicates that they don't see everything. Those people also might do orientation and mobility training. They might also get a guide dog. I don't know as much about those things because I didn't need it. A person with macular degeneration may also experience peripheral loss, so it just depends on the patient. The nice thing about a low vision doctor is they are individualizing what the patient needs. Tell me what problems you're having. Let's see if we have a device that can help you. At no point does the low vision doctor restore your vision. This is a permanent thing for most of us, but there are devices that can help. And certainly computers can do a lot of things, and accessibility features can change things, but they're not going to restore your vision to 2020. That's a hard reality, but the sooner you accept it, the easier it becomes. I did want to also mention bioptic glasses. I think I have a future slide on that, so I'm just planting the seed right now and we'll come back to it. If we could go 3 slides from now. Perfect. So this is the bioptic glasses that I wear. And for those of you who can see me, I'm going to put them on for the moment. So when I look through the glasses on a regular basis, they are no prescription The word has escaped me. The glass itself is no prescription. So when I wear these, I put my contact lenses in, and with my contacts, the best I can see is 20/110. So my vision has definitely progressed to not good vision. 20/110 means I can't see in the distance well at all, and I can't drive. I believe the cutoff for driving is between 20/50 and 20/70. So with 20/110 vision, I cannot drive. However, when I wear these glasses called bioptic glasses, they're also called telescopic bioptic glasses. When I look through the telescope, when it's positioned with the remaining good photoreceptors in my macula, I can see 20/40. Let me say that again. Here, looking straight ahead, my vision is 20/110. When I look through the telescope, my vision is 20/40. When my vision is 20/40, I am allowed to drive. So, I live in the state of Ohio. I went through what's known as the Bioptic Driver Training Program. I had to learn how to use these glasses appropriately while driving, and I learned it. So now I have a driver's license. You can call it a bioptic driver's license, but it's a driver's license. I am required to wear these glasses when I drive. I can only drive in daylight hours because my vision has progressed to the point that I have night blindness, and nobody wants a person who's night blind to be driving. So I only drive in daytime hours. In the state of Ohio, I drive 30 minutes after sunrise, and I stop driving 30 minutes before sunset. Those are my daytime rules. So in June, I have a lot of hours of driving. In December, in the winter, I have a lot fewer hours of driving. But that's the basics about my bioptic driving. If the main issue that I have with driving is reading the green signs that are in the distance when I'm on the highway, trying to figure out which lane should I be in. And so I will dip my head to look through the telescope to read the sign as I'm driving towards it. And I will only be in that telescope for 1 second. And then I pop back up into my regular vision, which is 20/110. So I'm only in the telescope 20/40 for 1 second, and then I'm back to normal. So why do I do that? Well, when you're looking through the telescope, you can't see anything else. You can see the stop sign or the green sign, but nothing else. It's very focused. But most of the time while you're driving, you want to see as much as you possibly can. So that's why I'm only in the telescope for 1 second. Generally, to become a bioptic driver, I had to have really good peripheral vision, which I have, and I had to have good contrast sensitivity, which I have. My issue was my macula was very little left. Okay, let's see what the next slide is. Okay, there's me driving or parked in the garage. I'm wearing a black filter on top of my glasses because it's sunny. And the filter actually fits on top of the glasses quite well. So depending on how much glare there is, I might wear that black filter on top. Let's do the next slide. Okay, so the story of my experience with vision loss is encapsulated in this book. When I started writing the book in 2019, I actually ended up with like 20 chapters, and I decided that that was way too much for anyone to bear. So I split it into 2 books. The first book was more my experience, and I think it's going to apply to more people being interested in it. The second book I'm still working on, but it's more of the science and the health and the vision research behind macular degeneration. So I would love to say it's going to be published in 2024, but I think that's unrealistic, but you could look for it in the future. And the science is going to be explained at a much more basic level. because I have found that even though eye doctors are really good at their job, they're not good at explaining the science to most people. And so that's why I'm working on this second book to explain the science behind it so that patients understand why they need to take vitamins, why certain things will help their vision and certain things won't help at all. So that's the second book. But in the first book, I talk about all the different changes that I went through. So chapter 1 was diagnosis story. Chapter 2 was coping and grieving. And I will tell you that every time I went to the eye doctor in the first few years, I anticipated the doctor was going to tell me, you can't drive. You've lost too much vision. And so I would build myself up of, this is going to be D-Day. This is going to be the worst day ever. And frequently it wasn't. But each time I lost some vision and my visual acuity got worse and worse and worse, I knew it was coming until eventually I did stop driving. So how do you find the book in case you were looking? It is called Invisible Disability, Living with Macular Degeneration. It is the sexiest topic title ever, don't you think? So if you are looking for the print copy, you can find it at 3 basic places. It is at Barnes & Noble. You can just request Invisible Disability. The author is Christine Donmoyer. If you can spell it right, that will help them. Donmoyer is spelled Donmoyer. Another place you can look is on Amazon. Amazon does provide a lot of books. And did I say 2 or 3? 2. There you go. I believe that you can get ebooks at both of those places. My friend tells me that it's available in Kindle, so go for it if that's your format. If you're more into audiobooks, you can get it at 3 places. iTunes has it, Audible has it, and Amazon. And each of those places provides it, so if that's the way that you're comfortable, awesome. The print version of the book, I went back and forth with my publisher so many times you cannot imagine, but I really wanted it to be large print, and she said that that would cost too much, and she's probably right, but we agreed on a slightly larger than normal font size. We agreed on a font that is more easy to see, and this is something that the macular degeneration crowd prefers. So that was new to me and it works, but is it large enough for a person with advanced macular degeneration? Probably not. Hence why the audiobook and ebooks might be other formats that you could use. But if you're planning to buy it for a family member or a friend who has good vision, the print version is awesome for them to help you understand what the patient is going through. Okay, what's the next slide? Okay, my take-home message, great. So let me remind you what the book also consists of. There's a chapter on science called chapter 3. So the only science is pretty much in that chapter. I've really minimized it so that it addresses a more broad audience. Like I said, the real science is going to be in the next book, which is not out yet. In chapter 4, I talk about eye exams, eye doctors, the difference between an optometrist and an ophthalmologist. And that's actually an important distinction for a patient. An optometrist can follow you every 6 months or every year. Yes, they're helpful with contact lenses and with glasses. They can also detect changes in your vision. The retina doctor or the ophthalmologist, they are more likely to do surgery. So let me say that again. An optometrist does not do surgery. They do not do injections. An optometrist is focused on getting you the best vision that they can. A low vision doctor is also an optometrist. Their focus is getting you the best vision that's possible. A retina specialist or an ophthalmologist, they are focused on the disease process and how it progresses. If you have wet AMD, they will probably offer you some injections. Since that's not my case, I'm not going to talk very much about it. There are other people who know more about which injections they would recommend. They sometimes do it every 4 weeks, every 6 weeks, and depending on how well those injections go, can preserve the vision that you still have. Those injections do not restore vision. A retina specialist will probably want to follow the patient every year. Sometimes they want to see you every 6 months, depending on how many vision changes you're experiencing. In my opinion, they are less interested in helping you function. They're more interested in just seeing how fast your vision is being lost. So, if I had to choose which doctor I would visit more often, I would visit the optometrist. That's my personal opinion. Okay. Let's see. In chapter 5 of the book, I talk a little bit about comparing Stargardt disease to AMD. Like I said, I think it's very similar to geographic atrophy. When a doctor has looked at my eyes compared to a patient with dry AMD, they say the eyeballs, the retina, looks very similar. The only difference is our age. So I take that for granted that I happen to have younger eyes, but they really look like I have dry AMD. That's the difference in my mind. The rest of my book talks about the adjustments that I made after visiting the low vision doctor, using the devices, and what changes happened in my daily life. There's a chapter on no longer driving, when I felt like I was 15 again. There's a chapter that talks about public transportation, the good, the bad, and the ugly. I have taken Amtrak. I have taken buses, Greyhound. I have paid various people for rides. And I was disappointed that people I worked with did not offer rides. But I conclude that I work with people who are very busy, who do not have time to drive me around. So when I was living in Pennsylvania and first not driving, first experiencing the ability to no longer drive my car, I was really in the grieving state. It took me 6 months to learn the public transportation system because I was still in denial of, oh, I'm going to have to get around again. I didn't realize what I would need. So I would encourage anyone who's going through these changes, who's no longer allowed to drive, to explore what are the local agencies that can help you. I was paralyzed, not literally, but mentally, in terms of asking for help. I describe that in several chapters of the book. Another thing that I describe in the book is my employment issues. One college I worked at, the answer I always got was no, 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 until I went to the dean, and then I got devices. At the next college I worked at, I got direct connection to the dean, and I actually had someone in human resources who helped get me devices and who kind of checked up on me every so often. And so when I was encountering problems with my department colleagues, like one of the problems seems so basic, but it was a real problem. We would have a department meeting and the chair would send out an email saying, this is the topics that we want to cover. Well, they would send out that email like 10 minutes before the meeting, so I might not have had time to read it on my computer. Or they would send out, they would print on paper a copy of the memo, but they would print it in size 11 font, which I can't read without devices. And so I would ask for 2 different mini accommodations. One, can you print out a copy that's in size 14, which I can read? It seems like such a small thing, but I cannot tell you how many times they would say, oh, sorry, Christy, I forgot to enlarge it for you. I know that if they had a student like me in their class, they would get it done. But because I was a colleague and because I didn't matter to them as much, I got put to the side. And I bet that some of you out there have experienced things similar to that. Of I requested something, but I didn't get it. Oh, sorry. Sending the things by computer seems really simple. Maybe you could send it like an hour before the meeting so I have a chance to read it. So I had to go round and round with HR and my department heads and explain to them, please send me something in a format that I could read. But at some point, I reached the conclusion that if they didn't want me to read it, I wouldn't need to read it. And so I would just come to the meetings unprepared. It's probably not the goal, but that was my reality for a while. If you can't send it to me in a format for me to read, I guess it's not important for me to read it. So there's various levels of resistance and pushback, and eventually I accepted the fact, but if you're not going to make it easy for me, if you're going to make it hard for me, I'm not going to play ball so much. Okay. Let's see. In the book, there's a chapter that talks about public transportation. There's a chapter that talks about employment issues. There's a chapter that goes through how I got my bioptic driver's license. Some people have told me that's the best chapter. It's chapter 12. Others say chapter 2 is the best, talking about coping and grieving. The very last chapter talks about disability and definitions. And what is low vision, talks about, am I visually impaired? Am I visually challenged? Am I legally disabled? Am I legally blind? So I guess I left this out, but between the year 2000 and 2006, I had very few vision changes. From 2006 to 2011, that's really where I experienced a lot of vision changes. I went from about 2040 to 2110. And those years were really tough on me because I relied on devices and I was still adjusting, trying to figure out in my work life and home life how to do things with vision loss. In 2011, I pretty much hit a brick wall figuratively. That's when the doctor told me my vision is 20/110. I can't allow you to drive home today. And so after crying a lot, I called a coworker and I said, can you bring another coworker and drive me and my car home? And so 2011 is when I began my period of not driving. And that was a devastating time. It takes time to grieve, but you can get through it. And it's not the end of the world to stop driving. But that's what I believed back then. It took 5.5 years for me to learn about the driver program in Ohio. I had to move to Ohio from Pennsylvania. It just so happened I was dating somebody in Ohio, so that's where it all came from. And I earned my driver's license. I can tell you that having a driver's license makes life a lot easier, but it's not the end of the world to not drive. Okay. So, one more little piece. Between 2011 and 2019, when I was working in Pennsylvania at a college, I actually asked the diversity officer, the chief diversity officer, am I disabled? And I look back now and think, well, of course you were disabled. At 20/110, you were legally blind. But I was operating on the knowledge that 2200 is legal blindness. And somewhere a couple years before 2011, the definition changed to 2100. So I was 20/110. I didn't know if I was legally blind or not. I just knew I couldn't drive home. Maybe the doctor told me this and I was just crying so much that I didn't hear it. Or maybe they never said it. I didn't know I was actually disabled in 2011. Kind of sad. It was in 2020 when I was writing this book that I discovered that I was legally blind 9 years earlier. Kind of pathetic, but that's my situation. So, if I could go back in time, I wish someone had told me about low vision sooner because I was really tense and nervous about the future loss of my vision. If I had known about the low vision doctors and providing assistance, that could have alleviated some of my fears. Second thing, if the doctor in 2011 had told me, by the way, you're legally blind now, go talk to this office to get some assistance, that would have helped too. Like I had to find it the hard way. I had to have various friends and family point me in the right direction. So the fact that you've connected to this organization, Vision Corps, I would like to believe that they're pointing you in the right direction to get resources. I certainly hope that was the plan for what Linda and her coworkers do here. I had to find out the hard way, but I did figure it out. So if you're interested in learning more about my story, certainly look at the book. But I think we now have plenty of time to answer some questions.
This is the end of our webinar recording. Thank you for joining. For more information about Vision Corps services, please call 717-291-5951 or email us at info@visioncorps.net. That's info@visioncorps.net.